Good morning, good afternoon, and good evening, everyone. Thank you so much for joining us for Power BI Dev Camp, a series that's been around for a long time that started with the amazing Ted Patterson from the Power BI CAT team. Today, we have the pleasure and honor of having Rui Romano, who's the Senior PM with the Power BI CAT team, who'll be walking us through how to monitor your on-prem Power BI gateways. Rui and Ted, how are you this morning?
I think we're doing well. Really? How are you doing?
All good. Thank you.
Fantastic, fantastic. Okay, well, without further ado, let's have it.
Okay. Well, thank you very much. As you know, we try to find developer-centric topics, that we don't shy away from going in depth, but something that's very applicable to what you do. And as you know, I work on the Power BI CAT team. And I have some very talented colleagues I work with, and Rui is one of those. I knew Rui before either of us joined Microsoft. Not that I knew him, but I knew of him and of his work. And now I just see him doing some great stuff. And for those who work in Power BI administration and monitoring and are looking for advanced solutions, I really love this talk that he's about to do. So without further ado, I'm just going to pass off to you, Rui, and say, thanks for doing our session this month.
Thank you, Ted. As Ted said, so we both work on the Power BI CAT team, and this session is all about sharing some work that we do sometimes with the most strategic customers, where we learn from them. And then ultimately, whenever possible, we scale those solutions and that knowledge to everyone. So today, I'm going to talk to you about a solution to effectively monitor and troubleshoot your on-prem gateways, starting with what is a gateway. So the gateway is just a bridge between your on-prem data sources and the Power BI tenant. So it serves like a bridge of standing data that exists on your local SQL servers or local data sources, and push that data to the cloud. And whenever you have one, or especially when you have multiple gateways, it's one of it is actually very challenging, and it's painful to manage and govern all those gateways, and things like that are simple, like just getting access to the gateway logs. It's a challenge because the gateway servers, they might be behind the DMZ, that might be protected by a firewall. You might, or the Power BI team might not get access to the gateway servers, and so just getting access to the gateway logs is a challenge, because, for example, the Power BI team that is working on a customer, if they need to get access to the logs, they need to open a service desk ticket, go to IT, and the IT team needs to remote desktop to the server, export the logs, and then give it back to the Power BI team. So this might take a lot of time, and sometimes when the Power BI team or the developer that is working on Power BI gets access to the logs, because sometimes there are information about the error, an effective way to troubleshoot a data set or a data flow refresh in Power BI, you need to get access to those logs. And whenever they get those logs, sometimes it's too late. They already fix it by trial and error. And when you get those logs, it's also not very easy to understand them. So we do have documentation on them, but it's not. So you do get a lot. You get like a big collection of log files, and just making the sense of all those log files is hard. And the more gateways you have, the more painful the process will be, especially. And just to give you an example, so the motivation to create this solution was by working with a customer that had at the time more or less 30 gateways. So you can imagine that just figuring it out which gateway was executing the data set, the refresh, and getting access to the gateway logs was very, very hard. Actually, I asked the customer, hey, what can I do to help you? And the only thing that they asked was for a centralized solution to get all the gateway logs, or to get easy access to the gateway logs, because it's a big customer and they were outsourcing gateway administration to a consultant, or to another company, and they definitely didn't want to give access, remote desktop access to the gateway servers. So that was their main ask, because each gateway will produce a certain set of logs, and it's centralized on each gateway. So if you want to get access to the gateway logs, you need to remote desktop to the gateway server, Windows server, and then export the logs and take it back. So that was motivation to create something like this. That is, it's a solution that in the complete way, because you can just use the Power BI template. I will show you how to do it. But if you want to deploy this, and if you have a lot of gateways, the main advantage that this solution will give you is it will centralize, it will make sure that all the gateway logs, they will be uploaded and centralized in the data lake, an existing data lake or a new data lake if you want. And the way I do it is it's basically having a PowerShell script that is deployed on each gateway server. So you need to deploy this script on each gateway server. And that script is very simple and lightweight. So you can have it running, I won't say every minute, but every 15 minutes, every 30 minutes. And the script will save the last execution time. And every time it runs, it will get the new logs since the last time it's run and upload that new log to the gateway server. And the other thing that the script will do is it will apply some metadata to the file. So it will discover the gateway IP. It will classify each log by year, month, and day, and partition that in separate folders. And it also classify the type of log. That are in the gateway logs, you have just verbals and error logs, but you also get some report logs that will log information like every query that is running on the gateway, and also some metadata logs that are very important. For example, logging how much containers the container configuration for each gateway. So in the end, what the blob storage or the data lake will have a folder for each gateway, and on each folder you have the logs. So this is a big advantage, because now you can give access to the logs to every team that you want. It can be the Power BI developer, or it can be an external company that needs to support Power BI. And you can even, because this is a data lake, you can even have certain access level or security on each gateway's folder. So that's a huge advantage, because now you get easy access to the log. So you don't need, as a Power BI admin or a tenant admin, you don't need to give permissions to the gateway servers, remote desktop permissions to the gateway servers to get access to the logs. And now you can just share a data lake connection and an access to a folder, or all the folders if you want. So this is the first advantage of doing this: centralization of the logs in a easy and central and secure location. Second, now that you have central access to the logs, now you can get insights about the gateways that you have access to. Not only one gateway, but you can, let's say, very easily view how much queries did your gateways run by each gateway, and see, for example, the distribution of the queries by gateway, and a lot other things that I will show in a minute. So you get insights about what's going on all your gateways at the same time. But also, Power BI, and we are talking about, by the way, log data, large text files with log data. Sometimes it's even difficult to parse those text files, and honestly, those files can get really big. And Power BI, and I did the best job that I can on optimizing the Power BI dataset and the Power Query to read those files, and even applying some optimization on the reading, like okay, only consider the certain types of logs, truncating the big text columns, filtering on the last X amount of days. But if you really wanna take this step forward to the next step, you probably need to consider other tools like Spark, ADX. So this can be considered a time series, so there are no changes in the history. So Kusto and Azure Data Explorer and Synapse can be better options to explore these logs in a more, let's say, real-time or near real-time approach. Although even on large tenants, I've been using the Power BI and it's enough, but I need to apply some kind of filters. I cannot look at, like, on a very, very high usage gateway, I cannot look into years of data. So I need to look, okay, let's look only to the last 15 days or the last 30 days. But since, and one more time, because the data, it's already centralized in a data lake, you easily can connect that data lake into a Synapse or Databricks or whatever technology that can connect to a data lake and explore those logs. Okay, so before going to the demo, let me just walk you through the GitHub. So everything that I'm about to show you, it's on a GitHub repo. I did the best job that I can on documenting the whole approach. So if you find it difficult to set this up, let me know, and I'm happy to enhance the documentation. So, but in here you'll find everything that you need. The most important things are the scripts. So this is the script that you need to deploy and run on each gateway server. It has a configuration file. That configuration file, the only thing that you should be required to change is the connection string to the storage account or to the data lake. Everything else, you probably can leave it by default. But if you change the location where the log files get stored, you also need to change the location. But by default, if you don't do anything, it's going to be stored in this location. And also, another thing that is very important is there are two Power BI templates that you can use. There is one called From Disk and one from Data Lake. But in the end, this is exactly the same Power BI implementation. I use a technique called file proxy because to have a single version of the development of this file, but I want to have two versions. I have one version that all the log data comes from disk, and this can be very handy if I don't want to deploy any of this. I don't want to have PowerShell scripts, but I don't mind manually exporting the logs, put the logs in the folder, but I still want to use the Power BI template that I'm going to show. You can do it. You just need to download the From Disk. If you want to deploy this to the lake and have a complete automation of the whole thing, you need to use the From Lake. But it's exactly, one more time, it's exactly the same template. So everything is documented, and how can you set this up? I will, in the end, if we have time, I will walk you through on how to deploy it. But it's as simple as creating a storage account or reusing a storage account, deploying the script, changing the configuration, run the script, and in the end, open the Power BI template, in this case, the From Lake Power BI template, and refresh it, and you are good to go. Okay, now let me show you the report, so the end result. Let's look at what you will get in the end. So in the end, after you run your after you deploy the PowerShell script to each gateway server and you run it, you will get a report like this. And And it starts by, let's start with the logs. So that is I will go through each page and explain how this logs, how this can be useful for you. The first page is just showing the logs for all the gateways. And what you can do on this page is you can search for a certain type of log. For example, I'm interested in seeing if I have timeout error. I can search for timeout, and this will filter, hopefully. Should have filtered the table. I don't know why it's not filtering. Maybe I should have a bug, or let me just refresh the page. Okay, this is a custom visual that I'm using. Maybe that is some issue. Timeout, for example. Okay, I don't know why it's not filtering, but maybe. But it will show all the logs that happen on all 4 gateways. And in here, the main insights that you can get is the trend. So the trend of logs, not only logs but also errors. So I may be interested in looking into the trend of errors. So I can see that, for example, in July 7, I got 4,000 errors. So this is a complete outlier comparing to the other day. So normally I should have like 26 errors, and I got 4,000 errors, and I can click and I can see on each gateways. So I had all those log errors in 3 of the gateways. So this was the main gateway. But by the way, another thing that I do like to do is I can right click, analyze, explain the increase, and this might get me a few insights about, okay, what's the main reason that contributed to that increase in the log errors. And you see some things that might be useful, like, hey, this activity type accounted for the majority of the logs between the one day to the other. Or this is the gateway ID. Actually, I can see that here. So gateway 2 is actually it's a gateway with more log errors between one day to the other. And of course, I can also see the details of those logs. And I can, for example, I can click on this on the gateway. I can even see, and I do like this visual over here. This was created by my colleague Chris Hamill. It's giving me like a heat map for each day and each hour. I can see the most active hour and day. In here, I'm filtering a single day, but if I unselect, I can see that's the 8th of 3 August 3rd was the day at the 19 hour was the day with the most active logs. And I can do the other way around. I can click on this heat map and I can see, okay, why I had more logs on that day. It was because of these 2 gateways that produced a lot of logs. Actually, not errors. This is probably telemetry report and some pool cleaner that happened on that day. Let's just go back to that day of the error. So I can click here. I can see the gateway. I can see the actual gateway errors that happen in here, and I can, for example, export this data to Excel and give it to the support team, or I can analyze this in a more text-friendly tool to see the actual log errors. But there is nothing more special about this page. So this is mainly useful to look at trends. So if I see something like this, or even on the logs, if I see a spike on the logs, it's also something that may not be normal, and I may want to pay more attention to it. Then
I do have a question
page,
when you have a second, Rui.
Go ahead.
I didn't mean to. There's one question. Maybe it would be a good time to come in. If it's not, I'm sorry for breaking your steam there. But
no.
So here's a question from Shankar. I see you pointing to 2 versions, Lake and Disk. To reconfirm, we can use the Disk version to access gateway logs directly from the server and not require data lake integration. Is this understanding correct?
Exactly. So the from disk, it's let's imagine this scenario. You go to each gateway, you copy the logs or export the logs using the gateway application, and you should end up with something like this. So in here, I have gateway logs from 2 gateways. So this was an export from the gateway. So I can copy this folder, and I can open the from disk template. So not the from lake, the from disk template. I think I already have it here, and you will see a parameter window like this. You need to specify the data location. In this case, it's not the default location of the gateway. So let's put the folder here, the folder that we just copied. I do have some optimization parameters, as I told, like, okay, I only want to look at the last 30 days of logs, because as I told you, these log files, they can be really big. So just to give you an example, I don't know. So in this case, it's not a very high usage gateway, but you can see that you will end up with like files with 20 megabytes, 30 megabytes, 100 megabytes. It depends on the usage that your gateway has. So, and also a few other optimization parameters like the truncation, because some log files, they do have like extensive log text or chunks of text. So one thing that I do, because normally at the beginning of the file, you have the information that you need. So I implemented two parameters that allow me to specify a truncation, the max truncation that I want to apply to the text column, because Power BI database is an in-memory column store database. So it's not the most efficient database to store big text columns, distinct text columns. So what I do to optimize that is, okay, I apply a truncate and I only get the 1,000 first characters. But you can, if you want, you can just change this, remove it, and this won't truncate anything. And a few other parameters to filter the data. For example, you might be looking into an export of 10 gateways, and you wanna, okay, I wanna just focus on gateway 1 and 2. This is especially useful also on the data lake if you want to have, like, let's say 3 templates with 3 gateways, with 3 different gateways to give access to 3 different teams. So you can reuse the same template and just change the parameter. Of course, you can also apply raw level security if you want, but this is an easy way to apply a filter and only consider the log files for that gateway. When you hit load, this will read the data log file from the disk, not the lake, and it will create. I won't wait for this, but it will end up with the same report. But it's exactly the same report. I don't have 2 versions of the Power BI development. I have a single version. Did I answer the question, Ted?
I think you did. I think you did an excellent job.
Very well.
I would never accuse you of over answering. All technical information is good.
Yeah, this is a developer session, so I can go deep. Okay, I will move forward if that's fine. Or do you have any other question?
You can go ahead. I'll call out if there's questions that come in text-wise.
Okay. Now, the second page, queries, this is where things start to get a lot more interesting, because in here, this will show you, like instantly, how many queries you have running on each gateway. How many of them are direct query? How many of them are imports? And just this, how many direct query, how many are imports? It's very useful information, especially if we are looking into a cluster, because sometimes I might I might have a performance issue on the cluster, and one of the reasons for that performance issue might be because I'm running at the same time direct query queries and refresh queries, import queries, and it's okay if this happen, but it's not okay if it's happening. Let's say you have a high amount of users and you have a high amount of direct query reports. At the same time, you also have a few or even a lot of Power BI in import mode, and they are refreshing at the same time as your users are viewing the report in direct query. So definitely the gateway will get a performance penalty, and it will have an impact on the performance of the gateway, and it may be a reason to consider splitting and have a dedicated gateway for direct query workloads and a dedicated gateway for direct query workloads, because they are completely different types of queries. So the direct query is just passing the query to the data source and getting the data and pushing the data to the cloud. The refresh queries, they go to the source, but if you have a Power Query transformations, it's way more CPU intensive and memory intensive, especially memory intensive, because it needs to serialize all the data and compress it and push it to the cloud. The direct query, they don't need to do it. But direct query, if you have a lot of users, you may need a gateway server with more CPU, because you will have more concurrency. You need to handle more queries at the same time. So that's why, for example, on direct query, you will see that you have a large amount of queries than refresh. If this report was a direct query report, this will generate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like 20 queries on a single report execution. Okay, so it's normal to see something like this, where the amount of queries in direct query is bigger than the refresh. But it's really important to know, as a Power BI admin, as someone that is responsible for the gateways, which type of queries am I running. So this will, and I cannot only see that, I can even see the type of data source that I'm running. So I can see that the direct query queries most of them are from SAP HANA. I can even right-click, drill down, and see which SAP HANA I'm connecting to. So you don't only get the information about the kind of the data source, but you also get information about the server the data source is connecting to. And if you do have a cluster, you will have information. Another thing that is important to understand on the cluster is the balance between the gateway nodes. So a big advantage on the whenever you create a cluster, a gateway cluster with multiple gateway nodes, is to balance your queries between the gateway nodes, and that balance is made randomly. It's a round-robin distribution. And I can see how that balancing is working. So I can see that gateway 2, 77K, gateway 1, 76K, but I can also see that through time, because I get access on the gateway logs. I have access on the queries up to the second. So I can see this aggregation, and actually the distribution is let's say not perfect, but it's pretty close. And an image and a visual, I can see that without having to look into the log files. This is very useful to quickly know, okay, I don't have a problem in balancing, or yes, let's say if these were a gateway cluster, then definitely I have a problem in the balance. That's not the case. Gateway 3 is not in the same cluster of gateway 1 and gateway 2. So distribution, classification of the queries, also how many queries or the percentage of queries that failed, also something that it's important for all the gateways. For a single gateway, if I click on the gateway, because this is Power BI, so everything will be it'll be interactive. So gateway 3 actually have higher amount of failures. I can click on the failures. I can see which queries got failed and the duration of those queries. Then looking to these visuals at the bottom, I can also see. Let's focus on a single gateway just to make it more easy to read. I can see the query execution, so I can see the amount of queries that I'm running, so the spike. So in this day, at May 25th, there was a high amount of queries comparing to the other days. I can also see the amount, how much were direct query, how much were imports, how much requests, and this is also an important measure because a request is let's say a dataset refresh is one request. That single dataset refresh may have 10 tables and it will generate 10 queries. So it's normal to the requests to be lower than the amount of queries because one request can have more than one query. So looking at the query execution, I'm just looking at the trends in terms of the amount of execution for each type of query. So this visual can get a little bit confusing, but I do like to see in the same visual all these 4 or 5 KPIs. Also duration, and duration, if we are looking at performance, it can give me a lot of insight. So I'm looking at, and I do have 2 axes in here. So on the left, it's the refresh, and on the right, the direct query, just because the numbers can be very different. So a refresh, it's very normal to have a very high duration. It can be 1 hour, and the direct query, normally it should be less than a second, 3 seconds, less than 10 seconds to execute. And one more time, looking at trends, so I can see that this day over here, it had an average execution of the queries that was pretty high. So the average execution of queries in this day was almost close to half an hour. The average execution, but one more time, I'm aggregating data to the day, but sorry, I do want to keep this too. So if I click on Gateway 3 and I click on this day, I can see all the queries that run on that day. So there was 7 queries, and I can see the duration. And yeah, so it actually happened. Some queries with a high amount of time. So and then I can look and see, okay, what was the query, what's the SQL, what's the kind, what's the data source type, and I can even see the actual Power Query or the query that got executed on the server. Also, another thing that I can see here is which gateway. And the reason I'm saying this, it's sometimes it's normal single data set refresh to execute queries in 1 or more gateways. So whenever you refresh a data set, don't think that all the queries will go to the same gateway. They will get distributed between gateways. So I can also see when I'm filtering on a single request, I can see the gateways that got executed, and also some KPIs about that query execution. And especially these 2 are the most interesting, because I can see the amount of time to retrieve the data, to read the data from the data source, and the amount of time to process that data on the Mashup engine. And whenever I see something like this means that the query was fast, but it spent like close to an hour mashing up the data. So this may be an indication that some optimization could be done on the Power Query to make the query more efficient. Okay, and I can even see some other metrics like the time, the data reading and serialization duration, the spooling to this duration, and also I calculate 2 KPIs: the average, the byte per second on read and the byte per second on write. I also show that those 2 KPIs, the byte per second read and write in a time series, because this may indicate. So if I do see, let's say, the disk write average going up, this might mean that I could have this problem. Okay, so we do get this performance count, the queries per day, so I can do an average calculation for all the queries for every single day, and get an understanding if it is if I could be having a disk issue or not. So
another question when you're ready to take one.
Okay, go ahead. Let's go.
So the question is from Pawan. I hope that's a good pronunciation. If not, I apologize. But would this dashboard show any data sources or connection strings, or only the log activity of a cluster?
It will show not exactly the connection string. It won't show credentials at all. Okay, if that's a concern, no. But it will show you
credentials. I would go to a different system.
Yeah, it will show you the server that is connecting. So this is actually the server from a SQL server in that gateway. So it will show you
like the server name and database name.
The server name and the database name. Yeah.
I think that would be the connection string information you would want, just to be able to scan and kind of see, what are the different data sources that we're talking to.
Yeah, so if you go to this visual over here and we drill down, I can instantly see that this server over here is the most active server in the whole gateway. It's a server with more queries. It has more than 148,000 queries that run on this server through time. And in this case, this server got queries from 2 gateways. So I did the demo from the gateway to the data source, but you can do from the data source to the gateways and see the actual execution of all these all the queries that went through to the server. What I mean is, you don't get here like the connection string that got configured on the Power Query, but you get the lineage, which server and which database you are connecting to. Another question, or can I move forward? Okay.
Oh, I'm sorry. There was one more follow-up question. Does it show what user is running these queries? Yeah.
No, you don't get the user information. And
it's
another
not
thing,
in the logs.
Yeah, it's not on the logs. And another thing that some of you may be wondering is, what is the dataset ID? Unfortunately, the dataset ID and the data flow ID is also not in the logs. You can kind of get to the same to that information, but it's not. I will show it in a minute. How can you map the queries to the actual data set or data flow refresh? Okay, so let's move forward. So we have like 20 minutes, right, Ted?
That is correct. 20 minutes, give or take.
Okay. So the next report, it's a report more for scalability, and it can be an indication that maybe you need to scale your gateways. It's just looking at concurrency and looking at concurrency in a certain for each day and by time slots. So you can actually change. So I'm showing this visual with for every single day. I'm dividing the day in 15-minute time slots that have queries running at the same time. So this basically is, I filter a gateway, and filtering that gateway, I can see the max. So there was, at maximum, there was 12 queries running at the same time in this period, in this day. I need to scroll it here. So, and I can see so at maximum on this gateway since ever, I only had 12 queries running in that 15-minute slot. So this may be, if you do see a high number here, that may be a reason to add another gateway to the cluster because you are running too much queries at the same time. You can also use that visual here because if you see like a big spike on queries running at the same time on the gateway, and if you know the amount of queries that it should be able to run, because you can also drill down and drill this to the hour. So I'm on a specific date, and now I'm focusing on a per hour. So I can also see per hour what is the most active time. So, for example, in this day, I had like 600 queries running. It's a lot of queries, but we need to also have in mind that we can click and we can see that most of them they are really fast. So they executed in a few milliseconds. So that's why I can execute a high amount of queries. But if those queries are slow, then they will end up queuing and that might be a problem. And a possible solution can be scaling and adding a new gateway node. Although I always recommend before considering putting more hardware, look at the data set, try to optimize it if possible. The most well-known optimization can be like incremental refresh. So you can, if the data set refresh is taking a lot of time, if you enable incremental refresh, you will only get the data that is changing and the data set. So the gateway query will be a lot more faster, and it will optimize and it will reduce the payload that will run on the gateway. So queries concurrency is just an indication of it's a KPI or an indicator that maybe you can consider scaling up the gateway because you are running at the same time a lot of gateways, a lot of queries. As a deep level, a lot more deep dive report into the logs is looking at the mashup log. And the mashup log, this report will only have data if you enable, let me show you, if you go to the gateway and you enable a setting of additional logging. So the mashup log doesn't get produced or doesn't get created if you don't enable additional logging. Let me see if this shows up. Actually, I think I have my gateway offline, but that is a setting on the gateway diagnostics that you can enable additional logging. So if you don't enable additional logging, this report will be empty. But especially when you are troubleshooting, let's say the performance of the gateway, this may have some critical information. And the most important one is an information about the amount of containers you have running on the gateway and the amount of containers that are pending for execution. So in that log, you will find some log entries that will tell at a specific time how many containers you are running and how many containers are on the queue. And I have seen customers where the pending, in this case, the pending is 45, the maximum pending that happened was 45, but I've seen situations where the pending is 100 or 200. And this is also a good indication that you may need to scale your gateways, add another node, because by default, and this is by default and according to the hardware that your gateway server has. So if you have an 8-core machine, the refreshes, you can have 16 containers running at the same time in parallel. So I cannot have more than 16. And I can see, if I click here on the default, I can see on this visual on the right, through time, when did I reach the 45 in terms of pending? So at this day, this was probably a spike, so I don't need to care much about it. But if I do see the pending happening every day, an amount of pending connections, let's say more than 10, that's a concern. That means that you are queuing, the gateway is not being able to handle all the gateway refreshes or the dataset refreshes that are running. And it also may be an indication that a scaling or optimizing the gateway might be a good idea. On the mashup logs, you also get let's say a deep dive into the query. So you do see the actual query that gets executed on the data source. You also you can view here some more detailed exceptions about what's going on. So you can focus on the exceptions if you want, or the errors by just clicking in here. And this is pretty internal log, so you don't expect to find documentation about this, but sometimes you will find your answer to a problem in this logs. So whenever there is let's say a troubleshooting on the gateways, on not only on performance but also on errors that are happening and you cannot explain them, the mashup logs can definitely help you out. And last, before going to the request, that's the final demo, the performance counters. So and see that for all the gateways. And in here is where I see a lot of value of having this solution when you have more than one gateway, because I can see for all my gateways how they are performing in terms of CPU, how they are performing in terms of memory. So on memory, I can easily see that I don't have a big issue other than on this gateway 3. But in terms of CPU, they are all fine. I can see that on the daily basis. I can also see this on the aggregation window, because the performance counter reports from the gateway, they are aggregated by default on every 5 minutes. It will collect the min, the max, and the average on each counter. So on the system, on the memory. So it's only in this case is this gateway. It's actually getting some spikes, and I also get some performance counter specific for the gateway. And this can be interesting because let's focus on this gateway over here. So I filter the gateway. I can see that, yes, I'm having a lot of times the CPU going to 100%, but the gateway CPU percent never went up than 5%. What this means is, because this is my personal gateway that is running on my laptop, what this means is that I'm running other things on my gateway that is not 100% gateway jobs. So this can be an indication that, hey, maybe there is other things running on the gateway that are not Power BI related, and you might. And by the way, I highly encourage all of you to, whenever you have a gateway, have a dedicated gateway if you can. Okay, if you can afford it, if you can deploy an individual virtual machine or an on-prem server just for the Power BI gateways. Don't mix gateway with Azure, the Data Factory integration runtime. It's never a good idea. It might work, but whenever you start to have more expensive workloads, it will end up badly. So if you can have dedicated gateways, please do it. And also, I can see the gateway memory consumption and also the mashup memory consumption, because each gateway, as I said, it will instantiate X amount of containers. So by default, for example, on refresh, it's 16 containers. And this is measuring the amount of memory for all those containers in a certain time point and the amount of memory for the gateway. So the mashup container will run the Power Query transformations. The gateway will aggregate all that data, spool it, and send it to the cloud. So also, one more time, and it's useful to correlate these two. If you see a high memory consumption on the gateway, but most of the memory is not from the gateway, that's an indication that other things are consuming memory. And the last demo of the report I want to give is just before going that, I also do like this page, especially when you have a lot of gateways. This will like profile each gateway, how many containers that you have on each gateway on each gateway by the type of containers. So direct query. So this gateway can run 40 containers of direct query at the same time, 48 of test connection pools, 16 on the default. That's the refresh. This is normally the most important one. So this is just profiling each gateway. Let's say sometimes we do see some variances like this. The gateway 3, it only has 12 containers running, and the reason might be because the gateway 3 has less CPU or less CPU cores than gateway 2. And sometimes the Power BI admin or whoever is looking at this report, they don't control the gateway hardware configuration, and this is an indication that certainly you should have the same type of hardware for each gateway just to get a better balancing. So the last is the requests, and this is a very important report, especially for troubleshooting, because this is every time, as I already explained, every time you refresh the data set, this will create a request ID, and that request ID will have logs and it will have queries. And how do you get that request ID? So if you go to your Power BI workspace, I already have one ready here, and you go to the refresh history. Whenever you get a refresh failure, you can show, and it will show in here the request ID. So you can copy this ID. You go back to the report and you filter the request ID. It's a little bit slow, but here it is. And I can filter the request ID. And I can see that, okay, this request took 36 seconds. I don't have any query. It failed, but I do have some logs on that request. And I can export those logs, or I can just view it here. And it may have some extra information that it's not on the error message that is saying unable to connect to the data source undefined. And I can do that for the requests that fail, but I can also do that for the requests that executed successfully. Unfortunately, on the UI, you cannot get the request ID for successful refreshes. But what you can do is you can use the APIs for that. So there is an API, get refresh history in group. You can learn more about that on the documentation. I do have this script also on the GitHub, and this script, it's basically, it will connect to the workspace, connect to the data set. I already executed, and it will list all the latest 100 refreshes that executed on the data set. And I can see the ones that failed, and I can also see the ones that were successful. And if I copy one of these IDs, and I go back to the report and filter the report with that request ID, I can also see not only, I can see the amount of logs. So you can see that a lot of logs got written for that single data set refresh, but I can see also the queries that got executed. And I can see the start time, the end time, the duration for each query, the query information for that for each query, and as we saw before, some statistics about which query and where it spent more time, if it was reading data from the data source, if it was processing and serializing the data on Power Query. Now, this is all very good, although one thing that it's not perfect is you cannot get the request ID from here, but you do have an alternative. But this only works on shared. Okay, this doesn't work on premium. If you have premium, the request ID that you have that is reported on the UI, this request ID, even on the errors, it doesn't map to the log. This is a known issue. The reason I'm telling you this is don't bother trying to map it, because sometimes it's not going to be reliable. That request ID is not mapped. So I'm saving you some effort if you are doing that. This will get solved. This is a known issue on the product team. I cannot get you an ETA for that, but it will get solved in the future. So what can you do? What you can do is you can do the old time mapping with the hour and the date and the time filter, and that's why the first thing that you see here in the top is the date and time filter. So you can, and this is all UTC, and the time that will show here, it will be UTC. The date time that you see on the report, it's also UTC. So I know that this refresh, this data set failed at 14th of November at 2:59 p.m. So I can go here and I can filter on the date that I want. So 14th of November. Yeah, that's it. 14th of November, and I can filter also so it should be 2 p.m. So 14. And I can look at all the requests. And one thing that really helps here is just looking at the query. So every request ID, because the gateway also logs requests that are not actually dataset refreshes. It's internal operations on the gateway. But if I filter on the queries, and I can sort it back. So this is actually probably one of this was the dataset refresh that run, and because it executed 5 queries, it ran on one gateway, and I can see the query. So, and after you got the correct request ID, then you can filter that request ID and focus on that. But that's the best thing that you can do if you wanna correlate a data set or a data flow refresh from the service to the gateway logs is by looking at the filtering the date and time. And this time, if I'm not mistaken, is the time that ends. So you need to look at this time at the time start, at the hour and the minute of the start and not the end. So
you have no doubt put a lot of time and trouble into figuring all this stuff out. I have one more question from Mark. Mark, thanks for asking the question. His question is, running the script on the gateway machine might also take up some memory. Do you have any idea on what impact the script has on the gateway machine itself?
So I've been helping customers, and really large customers that with a lot of gateways. I didn't see any impact or major impact on running this PowerShell script on the server. One thing it's important, I don't read the files on the script. So the script is basically the only impact that it may have if it is a very high usage intensive gateway. I can tell you that you can easily end up with the files close to 100 megabytes in size. It's a network, but not the memory, because the PowerShell is not going to read the file. It's just going to get the files that got modified and upload them to the storage account. So if you have this script running every 15 minutes, that's fine. You shouldn't see any impact on the gateway other maybe than the network. But if you run it every 15 minutes, the amount of files that will get uploaded are pretty small.
Great. Thank you for answering.
And I know that I'm already running a little bit out of time. One more time, the entire process is documented. I already briefly explained what you need to deploy this. You need a storage account. After you get the storage account on the Azure portal, you can get the connection string. The configuration, you just need to put the connection string on the storage on the configuration, and that's it. So you run the script. The script will figure out the gateway ID by looking into the logs and reading just the first line of one of the logs to detect the gateway ID. And in the end, you can schedule that PowerShell script on a schedule task or whatever scheduler you want, and then use the template that is appropriate. But one more time, it's if you want, you can, if the report interests you and you don't want to deploy any PowerShell scripts, you can just use the template and directly point to the gateway log exports that you have. And I just want to close with this remark that I stole this from my colleague Alex Powers. So I know that I showed a few things, especially the PowerShell can be a little bit overwhelming, but I'm sure that in your company or in your team, you do have someone that can understand this and deploy this. And this is the important thing. It's knowing what is possible. It's not about what you know. Thank you very much. And I hope that this was helpful and it will help you better and more efficiently monitor the gateways and the on-prem gateways that I know that it is a struggle.
Thank you very much, Rui. That was an amazing session. And we appreciate you, the audience, those who are seeing it live, those who are going to watch the recording, and we really hope this helps you out and that you look at Rui's sample that he put up there in GitHub. So with that, thank you everyone for attending. Thanks for watching. Cheers.
Thank you. Bye-bye.